Hello guys, I will try to record this video again. It's our 2.3 tangent and cotangent graph. In order for us to graph our tangent and cotangent, let's start by thinking about how exactly does the graph looks like. To do so, we will use our calculator. However, this is a non-calculator unit. Now on your calculator, I want you to write y equals tangent x on the y1, and on the y2, I want you to write cotangent x. Keep in mind, cotangent is cosine of a sine. I do not want you to write 1 over tangent because it will make a little difference. Once you complete this, if you go under your table, make sure your calculator is in degrees, and make sure also that your table set is set to the point that it starts at negative 180, just as on our paper, and it will go every 15 units. So on your table, you should be able to get all the values. I want you to copy all these values on this table on your worksheet. Instead of copying all the values, personally, I decided to write just the one that are whole value, such as at negative 180 I have 0, and error you put undefined instead of error. At negative 90, for example, I have an undefined and a 0, 1 and 1 at negative 135, and so on. So for the sake of time, I will let you complete this on your own. Let's go back to our worksheet. So we completed number 1. You should be able to do it by yourself. Number 2, it says plot the graph of y equal tangent x and y equal cotangent x on the appropriate set of axes. These axes are given to you on the last page of your notes. Now, I went ahead and graphed my tangent already. How does the tangent looks like? It is my purple shape here, or my purple graph. Wherever it was saying undefined, let me go ahead and bring my calculator back. Wherever it was saying, keep in mind y1 is my tangent. Wherever it was saying error, such as at 90, I will have a dotted line. This is called my asymptote. At 90, I will have a dotted line. And at negative 90, I will also have a dotted line, meaning an asymptote. And you will be able to graph a full cycle. I show you exactly these graphs before, and I know you have seen it before. But the tangent graph always increases, and the parent function of the tangent of x goes through the origin. If we compare it with the cotangent while applying the same rules, such as the asymptote wherever we have an error, and you will notice that the cotangent is a decreasing function. Cotangent is always decreased, and at at x equals 0, you will have an asymptote, and that is my pink line. Now, when studying the cotangent and tangent, you will study it the same way you did with the sine. The only difference will be the shapes. But there's one more difference. Let's start by looking at the similarities and differences between the cotangent graph and the tangent graph. I will start with tangent. You mentioned this in class already. The tangent will pass the point 0, 0, meaning the origin. Compared to the cotangent we have x equals 0 is an asymptote. The other main difference is the fact that tangent is always increasing, while cotangent is decreasing. What is the period of y equal tangent x? This is what makes the tangent different than sine and cosine. The period, first of all. On sine and cosine, you remember the period is 2 pi over b. Instead of 2 pi over b for the tangent and cotangent, it will just be pi over b, not 2 pi over b. Or you can also say 180 over b. In general, where do the asymptotes of the y equal tangent x occur? Now, tangent is sine over cosine. To know where you will have an asymptote, think of what makes the cosine equal to 0. What makes the cosine equal to 0 is 90 degrees. So it will occur every 90 degrees plus pi 180n, plus or minus, of course. Or you can always say pi over 2 plus or minus pi n. Keep in mind, what makes the cosine 0 is 90 degrees, or pi over 2. If we want to do the same thing for the cotangent is cosine over sine. So what makes the sine equal to 0 is 0. So you will have 0 plus or minus 180 n, or 0 plus or minus pi n if it's in radians. Let's go ahead and graph our own tangent function now. I will start with number 1 that says tangent of 1/4 of theta in degrees. To graph this, I will start by saying, what is the value of b? B is 1/4, so the period is equal to, here is pi. Since theta is in degree, I will say 180 over 1/4. And if you divide 180 by 1/4, what should you get? You should get 180 times 4 instead, which is 720. Let's go ahead and now find the critical point. The critical point will be 720, now divide by 4. And if you do 720 by 4, you get 180 degrees. All right, let's go ahead and label our axis. The first point I will have, of course, is 0. After 0, I will have 180, 360, 540, 720, 900, 1080. Since I ran out of room, I also need the negative side, so I will do negative 180, negative 360, and here I will also have, I can go further and say negative 540. I don't know yet if I will need it or not, but I do know that I will start at 0 because there was no vertical or horizontal shift. Because it's tangent, I know that it goes through 0. Now, since it goes through 0, from 0, I know that if it goes through the first one being 0, the period is 720. It means that 720 units later, I will have another point where it will go through. So at 720, it will go through this point as well. So where do you think the asymptote is? It must be in between these two, which is the very middle. So I will go ahead and graph the asymptote. I will have an asymptote here at 360. And I will also have, if I have one at 360, I will have one here also at 1080. If I have one, I will also have another one here at negative 360. Now, another way to find where your asymptote is, and I mentioned this before, is here. Let me just show you. This is the other way to find the asymptote. If it's tangent, you do 90 plus or minus pi n. So here, if you do 90 plus or minus pi n, you will be able to find the location of your asymptote. All right, from here, I feel like I made a mistake. This is not supposed to be here. It goes to 0 to, yes, that's right. All right, to graph your line, you know that tangent is increasing, so you need an increasing function. It will go from here, go through this point, come back and rise. The same thing on the other side. It will rise, and that will be your tangent function. This is 2 complete cycle. If you want to graph a little more, if I have 2 more dots here, I'll be able to graph the beginning of, actually the end of another cycle. And if I had 2 dots here, I'll be able to graph the beginning of another cycle. Let's do the same thing, this time with cotangent. For cotangent, I will start by looking, of course, for little details, such as the period. To find the period, I will say is, since it's in radian, pi over 6. And if I do pi divided by pi over 6, what do you get? You should get exactly 6. Now that you have 6, yes, pi divided by pi over 6. Let's go ahead and change this from pi over 6 to 1/6, because if not, you will not be able to solve it. If it's 1/6, I end up with 6 pi as the period. Therefore, the critical point is equal to 6 pi over 4, which is equal to 3 pi over 2. So I will go ahead and label my axis. If this is 0, the first one is 3 pi over 2, which is here. After 3 pi over 2, if I add another 3 pi over 2, I will have 6 pi over 2, then 9 pi over 2. After 9 pi, I will have 12 pi over 2. I'm running out of room, so I will do the negative side. Negative 3 pi over 2, negative 6 pi over 2, negative 9 pi over 2, and let's say negative 12 pi over 2. We will see if this is enough for 2 complete cycles. Keep in mind, this line is an asymptote for the cotangent. Since it's a cotangent, it does not go through the origin. So let's go ahead and first start by graphing our asymptote. Our asymptote is at x equals 0. Now, our period is 6 pi. It means that 6 pi later, we will have another asymptote. If I count 6 pi, it will be at 12. So at 12 pi over 2, I will have an asymptote, and it will be the same at negative 12 pi over 2. Now, the cotangent graph is a decreasing graph. So I will graph a decreasing function, starting from here. And of course, the center in between the asymptote represents where it's going to cross. And it will be also a decreasing one here. Just as I did on the previous one, you can always get 2 more marks. With these 2 marks, this one will be the ending. And with 2 marks here, it will be the beginning. All right, let's go ahead and deal with the last 2. I will do 2, and I will let you do maybe the last one or this one. I'll let you do number 4. Tangent of 3 pi, same concept. The first thing I will ask myself is the period. And the period here is equal to, since it's in degree, 360 divided by 3, which is 120. The CP, on the other hand, is 120 divided by 4. And if you divide sorry about this, 360 is for sine and cosine. So let's fix it. The period instead is supposed to be 180 divided by 3. And 180 divided by 3 is 60. And the CP is 60 divided by 4. And if you divide 60 by 4, you get 15. So if I start at 0, the first mark I need is 15, followed by 30, 45, 60. And I like some on the negative side too, negative 15. Keep in mind, you can graph on either side. You can continue here as long as you make sure that you have your y intercept. Negative 30, negative 45, and I can go up to negative 60. Why not? And let's see if we have 2 complete cycles. It's a tangent, so it goes through the origin. And if it goes through the origin, the first one that I'm sure it will go through is this point. My period is 60. So after 60, I will have another point where it will go through. Same thing here. So my asymptote is obviously in between the 2 points of the intersection with the x-axis. And let's go ahead and graph those tangents, those asymptotes. The asymptote will be here and also here. Knowing that the tangent is an increasing function, I'll go ahead and make it my increasing function coming from down here. Let's change colors. Coming from down here, going through our 0 and increasing. Here I only have half of it, so it starts from the bottom. And this other half will be on top. You can always keep going to get more if you want. I'm leaving number 4 for you, but I will do the last one. This time I have the cotangent function. Cotangent is the decreasing function. Let's start with the period. The period of a cotangent function is 180, since it's in radian, is pi over 2. Therefore, the CP is pi over 8. So I'll start at 0. The first mark, of course, is pi over 8, followed by 2 pi over 8. That's 2 pi over 8. That will be 3 pi over 8, and 4 pi over 8, 5 pi over 8. And if you keep going, let's go ahead and stop at 6 pi over 8. And I'll do the same thing on the back. So this one is negative pi by 8, negative 2 pi by 8, negative 3 pi by 8, and so on. Now, cotangent, it has the x-axis as an asymptote unless it has been transformed. Because later on, we will be able to shift that asymptote to the left or to the right. So for now, since it's just a regular cotangent function, we know that an asymptote is located on the x-axis. So I'll go ahead and draw my asymptote here. The next asymptote will be pi over 2 later. The one that is giving me pi over 2 is here. After that, I have another pi over 2 later, meaning if this one was at 4, the next asymptote will be somewhere here all the way to the back. But let's see if we have enough to complete 2 full cycles. I know it's going to cross here, 2 units, it's going to cross here, 2 units, it's going to cross here. So to graph this, knowing that it's a decreasing function, I will start high up there and get close to the axis. This one will be from here to the point, and this one on the other hand is going to be the end. Keep in mind, you can keep going and you can build more than this. Don't forget to complete this problem for next class period.